Let's talk about drag forces. Before we begin, let's ask ourselves a question. If dropped simultaneously from the top of the Empire State Building, which weight will hit the ground first? Mass 1, which is 200 grams, or mass 2, which is 500 grams. What does our observation tell us? So the possible answers could be mass 1, mass 2, or that they both will fall at the same time. Our general observation says that mass 2 will fall faster than mass 1. Now it's the same question, slightly changed. If dropped simultaneously from the top of our table in our classroom, which weight will hit the ground first? Again, the same possible answers, mass 1, mass 2, or they will fall at the same time. So now let's talk about why certain things do certain things, right? And in order to talk about that, we are going to talk about drags. So let's talk about a story of an elephant and feather. So in the late 1500s, an Italian scientist named Galileo Galilei proved that objects fall to the ground at the same rate because the acceleration due to gravity is the same for all objects. For example, an elephant and a feather fall with the same acceleration even though they have different masses. So gravity and acceleration. The rate at which the objects accelerate towards the Earth is 9.8 meters per second squared. This acceleration is the same for all objects, regardless of their mass. In other words, falling objects accelerate at a constant rate of 9.8 meters per second squared. Note, the ball is not traveling at 9.8 meters per second, it is accelerating at 9.8 meters per second squared. So in general, the ball's velocity will continuously increase. However, its acceleration will remain constant. So if you were to look at this picture, which is taken every second as the ball is falling, you will note that in the first second it only travels 4.9 meters, second it travels a further 14.7, and a third second 24.5. So basically it is speeding up as it is going downwards, right? So which is equivalent to what we are saying, that its speed is increasing. So its speed was initially 0, then it's 9.8, then it's 19.6, and then 29.4 meters per second downwards. In order for this scenario to be true, let's look at raindrops that fall from the sky. And in general, they fall from 2 kilometers or 2,000 meters above the Earth. So if we used equations of motions, the raindrops, by the time they reach the ground, should have about the speed of 200 meters per second, or about 400 miles per hour. So as a reference, look at Indianapolis 500 fastest qualifier, whose speed was 226 miles per hour. Interesting. If a raindrop were to hit you with that speed, you will die. Have you ever seen a raindrop with that speed? And the answer probably is no. No one has seen that speed. So how does that work? So drag forces, right? So it could be an error that we've made in our equation of motion. And the error that we've made is that we've ignored a drag force. Drag forces are frictional forces exerted by air on falling raindrops. This frictional force, or drag force, is experienced by the object that moves through a fluid, for example, water, or a medium like air. Here's an activity I want you to do. So take 2 pieces of paper, crumple one up into a tight ball, and keep the other one flat. Go up the stairs in your house and drop both of them, and see what happens. You will see that the crumpled paper will fall faster. It will have more velocity. It will hit the ground first, whereas the flat paper will slowly glide to the ground. So, a free fall is a fall where an object is let go of from a certain height and allowed to fall by the effect of acceleration alone. So you can think of it as a projectile motion just dropped. If we were to take all air resistance out of the picture, the feather and the ball, dropped from the same height, will fall to the ground at the same time. However, in air, one of the objects is longer than the other one. So now let's talk about drag forces. So drag forces are the forces that are experienced by things falling from the sky. For example, this parachuter. When he's falling, he will just fall straight downwards until he opens his chute, and at which point that will slow down his descent and he can just glide down to the earth. So drag forces impose a condition on the maximum speed that can be attained by any object. They depend on the speed of the body, properties of the falling body, and the properties of the medium themselves. In general, drag force for a certain medium, for example, air, is generally given by B, which is a constant depending on the material that you are walking through and the speed of the object. So drag force is directly proportional to how fast the object is going. So for an object falling under the influence of a drag force, these are the equations that we are going to use instead of the equations for the acceleration, velocities, and the displacements that we have been using, which we've been calling equation of motions. And these are the equation of motions that kind of save us from, killer raindrops from falling from the sky.